Now let's look at symmetric difference. So this set operation, symmetric difference, which is represented like this between two sets, A symmetric difference B. That's how we represent. This is the symbol for symmetric difference. And this set operation gives me what region? Gives me the elements of A and B that are not common. So this gives me those elements of A and B which is not in the intersection region. That is the elements of A that does not belong to B and elements of B that does not belong to A. This will give me a set that has element X belongs to A and X does not belongs to B, or X belongs to does not belongs to A and X belongs to B. Okay, so this is what your symmetric difference is. For example, if I take an example for A is equal to, let's say, 1, 2, 3, 4, 5, 6, 7, and B is equal to 5, 6, 7, 8, 9, and 10. Then what would be the elements in A or B? Elements in A or B will be everything apart from 5, 6, 7, because 5, 6, 7 is the intersection region. 5, 6, 7 are the common elements. So every element other than 5, 6, 7 will be a part of this A or B. For 1, 2, 3, 4, these conditions are fulfilled. So they will be a part of A or B. 1, 2, 3, 4. 5, 6, and 7 are common elements. So they will not be an element in A or B. 8, 9, 10. 8, 9, 10 fulfills this condition that they don't belong to A but they belong to B. So 8, 9, and 10. So this is what your symmetric difference is. Last set operation is, if you look at this complement set operation, then complement is a unary set operation. A complement is equal to all the elements X such that X does not belongs to A. X such that X does not belongs to A. So clearly, what is this element then? It means that A complement is equal to universal set minus A. Right? So A complement is all of this region. All of this region. Apart from A, everything. That is your A complement. All of this, every element in this region is A complement. Is an element in A complement. Now that you know all of these set operations, their fundamental definitions, now you can derive many formulas. So when you know the definitions and you have the Venn diagram, then you can form different equalities. What I mean to say is this. Look at this diagram. It is clear what is this shaded region. This shaded region is B minus A. This is one set. This is one set. So if I write equal to and write something here, then this has to be a set, and this has to be a set that is equal to this set. Means on both sides, if I, let's say, if I B minus A, if I write it as S1, set 1, then I may have different expression of set operations, but ultimately ultimately it will evaluate to one set, and let that set be S2. And if there is equal sign in it, then it means that the elements in S1 and elements in S2 are same. Okay. you can equate b minus a with respect to other set operations. How? For example, look at this. This is your region that you want. This is your region that you want. Can I not say that from the set B, from set B, I want to remove this region from the set B. I want to remove this region, this region. So I can say that B minus A is equal to B minus A intersection B. Will I be wrong to say that? No, because this region is nothing but B intersection B. So these two sets are equal. S1 and S2 are equal. So from the Venn diagram, you can write a lot of different expressions which will evaluate to the set which is equal to S1 or which is equal to B minus A. How? What other way can you write this? You can write B minus A. You can write B minus A to be equal to, because you just have to remove this part. If you want to remove this part, B minus A is equal to B intersection A complement, B intersection A complement, because A complement means apart from A, so you will have everything apart from A, but A complement will not include this region. So the common elements is just this. So you know what? From Venn diagram you can write these equations. Okay, and there's another way to prove. Another way to prove this would be how you can prove it. When you have two sets, and to prove the two sets that they are equal, if you have these two sets and you have to prove that whether this equation, okay, let's say this is the left hand side and this is the right hand side. So to prove the equality, you just have to show that LHS is equal to RHS. And in this case, what you have to show? You have to show that this set, which is S1, this set which is S1, that has to be equal to this set which is S2. You have to show that S1 is equal to S2. So how you will show it? Using the fact that when two sets are equal, both are subset of one another. Like if S1 is subset of S2 and S2 is also a subset of S1, then S1 and S2 are equal. That's how you show it. Then how do we do that? We do that in this manner. Like if means I will take that for that X belongs to B minus A. I will take this, that X belongs to B minus A. So what does it mean? It means that X belongs to A and X does not belongs to A. X belongs to B. X belongs to B and X does not belongs to A. Right? And what does this mean? X belongs to B intersection A complement. What does it mean? It means that X belongs to B and X does not belongs to A. So both are same things. So they are equal. Okay, my plan was to cover this remaining two set operations and then move towards the laws of these what laws these different operations conform to and not conform to. And while explaining those laws, I would explain this, that when you have an equal sign, then you just have to show that the two sets are equal, and the way to show two sets are equal is one of the way is you can just visualize it using the Venn diagram, and which is an easy process. And the another way is to just go to the very fundamental level of what you know about definitions, and then just prove that both sets are equal. You can prove that how every element in this set is also an element in this, and how every element in this is also an element in this, which is to prove that this set S1 is a subset of S2 and set S2 is a subset of S1. So I hope that if this part is not clear, then these two set operations are clear. So in the next video, I will explain different laws that these set operations satisfy or not satisfy. That video also I will deal with these things. So if things got messy a little bit here, because this was not in plan to go right away, but because I have made the video, I will keep it. Thank you very much.